Well, let me start by offering my appreciation for our Chancellor's for his vision. I'm delighted that he challenged us to become next Silicon Valley, and such a challenge, first of all, having vision is critical for anyone to get there. So that is the most fundamental thing, most important thing that he has given us. I'll be remiss if I did not call out tremendous leadership that our President, Dr. Hopkins, has shown, and also his entire leadership team, Dr. Engel, Dr. Bantlong, in identifying and promoting these centers of excellence. And Dr. Jang, Dr. Sitkem, thank you very much for your early and steadfast support for Kno.e.sis. In the 16th century, Francis Bacon, an English philosopher, statesman, scientist, lawyer, jurist, and author, established deductive methodologies for scientific inquiry. And he said something that is more true than ever. He said, knowledge is power. That would drive what we are going to talk about today. We have moved, our society has moved from agriculture to industry to service to knowledge, and we are a knowledge economy. And with that, knowledge has become the principal component for value creation, productivity, and economic growth. That is the fundamental aspect that drives what what our center is going to enable further on with the use of computing. So let us one interesting study of OECD countries for over a decade showed that 75% of the new value creation, growth creation, was because of knowledge services. And not only in the IT or high-tech areas, but in even all the traditional areas of all the traditional industry sectors, the majority of the growth came from these so-called knowledge industries, knowledge services. So let me give a technological introduction to how the knowledge services are created and what they are about. Let's face it, we all face today a fire hose of data, and something like PubMed adds 2,000 to 4,000 articles, publications a day, citations a day. Or if you run a scientific experiment, you would be creating, through just one run, 5 gigabytes of data, and you'll be running many such runs in a scientific experiments. And think about all the data that all these cameras are generating that can be posted, many of them are posted on the web, on the Flickr and other things, and think about all the data that 40 billion sensors are generating. Right? So we face massive amount of data. And we have developed techniques for search and browsing. So we can find some piece of information, some piece of data. That has only given us information glut. Like what our brain does, when we use our own knowledge to assimilate the information and to make sense out of it, to make the meaning out of it, and to make decisions. Similarly, our research is about applying domain models and background knowledge to meaningfully tag all this data automatically, by and large. We go on Flickr and put a tag, but instead think about computer programs doing this automatically to associate meaning to the data. And once we have done that, we use a bunch of computational techniques to allow you to discover the knowledge, to allow you to gain situational awareness, to allow you to gain insight. Right? So that is generally the idea. And if you look at the example, I showed here all this kind of biomedical data. A scientist would be interested in asking, how can we treat migraine? Or what does magnesium has to do with migraine? Or what does magnesium deficiency, why does magnesium deficiency cause migraine? Or what process is used by which magnesium affects migraine? So these are the kind of questions that scientists would ask. And these are the insights that one needs from this massive amount of data. So the knowledge enabled computing is about using knowledge and computing to deliver this kind of promise. So our vision is then, we want to step away from the focus on storing and searching the data, from number crunching to text processing, and into improving human experience, human effectiveness, human performance, and human productivity. That is broadly the vision of our center. Why Kno.e.sis? Because we have exciting vision that is built upon cutting-edge research and technology. Because we incorporate synergy to carry out this exceptional vision. Many of the difficult problems today cannot be solved by a person in a single discipline. You have to come together. We are world class and recognized as such. That our track record shows that we can succeed, and that we target the growth aspects of the economy of this region and the state. So the way the center is, fits in to our ecosystem is like this. We have 15 faculty, and they have strength in some of these core areas that are listed there. And just as my position was created by the Third Frontier, so was Data Ohio, a right center of innovation that provides infrastructure and partnerships. And we are able to serve 3 of the 4 major areas, industry clusters that Data and Development Corporation has identified that are of critical importance in this region. And they are listed there. And the idea is that we are already working with major industry and government organizations in this region. And in the process, then we are creating globally competitive careers, and we are aiding to economic development. And later on, Terry and Jim will say more about the economic aspects of it. We are 15, tending to 16 faculty members. The interesting and important point is that we have been already working together. So this center is not something that just got formed, it is bottom up, where we have been working on, we have been jointly funded. We have made many funding proposals. We fund on committees of our colleague students, and so on and so forth. So we have exceptional infrastructure. 75% of Joshi Research Center is occupied by those associated with the center, and we have cloud computing infrastructure and 12 different labs that are directed by the faculty belonging to the center, as well as we bring together Center for Healthy Communities. Along with that, there's a significant amount of infrastructure and capabilities that our center has. We have exceptional local original collaborations. For example, currently we have 6 actively funded projects with Air Force Research, both the directorates that are in this area, and more under discussions. We have large number of national collaborations. Most of these are funded collaborations, funded by NIH, NSF, things of that nature. And what is unique is that right here, while we are away from Silicon Valley, we have received funding in last 18 months from Microsoft Research, IBM Research, HP Labs, and Google. That's quite a story. And we have a whole bunch of international collaborations. We are an official member of World Wide Web Consortium, from which a standard has already been adopted. So now I'll pass on to the next speaker. Meena is going to talk about the knowledge and the next generation of the web. And the context of this is as follows. We started out with Web 1.0, whereby it was web of documents and media. And then we got into Web 2.0, web of people. And now we are getting into web of meaning. And so, at the same time, internet and web has become the core infrastructure that every business needs, and that every industry needs. So what do we do in embedding knowledge-enabled computing into this infrastructure? Some of the samples, given the time, Meena will talk about 2 or 3 of those samples. Meena. And Meena is a PhD student in the center.